Very good morning. Um, Today we are going to see about a database schema for decision support. So, database management system is a way to organize the data in an efficient way. So, when you are going to take a database, it has only arranged data in the form of tables. So, like a row and column. But when you're going to take a decision in a multiple dimensions, we need to have another kind of data structure that is called the data cube. So here the data cube allows data to be modeled and viewed in a multiple dimensions. It is defined by dimensions and fact table. So in general terms, dimensions are perspective or entities with respect to which an organization wants to keep records. So very simple. So the dimensions is nothing but the attributes are related with the organization. We want to store the information. So there is a dimensions. So example, when we are going to create a sales data warehouse in order to keep records of the stores sales with respect to of dimensions like time, item, like product, branch, and a location. So our objective is to store the information like a time, item, branch, and a location. Each dimension may have a table associated with it called a dimension table, with further describes the dimensions. A dimension table for item may contain the attributes item, name, brand, and type. So when you're going for a item that is a product, the product has a specific product ID, specific product name, then brand, and type of a product is like that. So in a multi-dimensional data model is typically organized around a central theme like a sales. For instance, this theme is represented by a fact table. So the multi-dimensional data model is it has a two different terminologies. One is a fact table and dimensions. So facts are numerical methods. So for example, facts for a sales data warehouse include dollars sold, units sold, and amount budgeted. So this is a simple example diagram for a multi-dimensional data model in terms of data cube. So here it represents the locations, items, and time periods the particular product sells. So with this diagram, I'm just explaining what it defines. So we have a four different item types: home, entertainments, computer, phone, and security. In a time column, it has a quarter one, quarter two, quarter three, and quarter four. And a location with locations are described in terms of cities. So Vancouver, Toronto, New York, and Chicago. So here, for each in a particular item, that is a type of item is sold in a particular city with respect to of the quarters. So from these data model, we can easily provide information to the customers. So here we have a three different kind of schema. One is a star schema, and another one is a snowflake schema, and fact consultation schema. In the star schema, the most popular data model for a data warehouse is a multidimensional model. A data warehouse contains, so we already defined that the fact table is nothing but it is a central table. It consists of bulk of data with no redundancy. Yes, a set of smaller associate tables, one of each dimension. The dimension table display in a radial pattern around the central fact. So this is the example for star factor. So the central table is called sales table. It is the fact table. So around the fact table, we may have a multiple dimension table like the item dimension table, location dimension table, branch dimension table, and time dimension table. So it is a very simple so it has some very simple structure. Through the structure, we may easily understand what happened in the architecture. And a great query effectiveness, a small number of tables to join, a relatively long time of loading data into dimension tables. The snowflake schema, the snowflake schema is a variant of star schema model where some time. So here there is a chance of duplications. So in the snowflake schema, it is going to normalize the data. The further splitting the data into additional tables, the resulting schema graph forms a shape similar to snowflake. So here the sales fact table has a number of attributes like time key, item key, branch key, location key, dollar sold, and units sold. So the location key, again, it is it creates another location dimension table like location key, street, and city. Again, the city key is divided into city, district, or a state, and country. So this is the way of creating a snowflake scheme. And the major difference between the snowflake and the star schema model is the dimension table of the snowflake may be kept in a normalized form to reduce redundancy. So this table is to maintain and save storage spaces. The last one is a fact consolidation schema. So it has a multiple fact table to share a common dimension table. So in the next slide. So in this slide, we have a single fact table, a one dimension table, but more number of fact tables. So like sales fact table, and here you can see that fact table, and this is the shipping fact table. This is the fact table. So the one dimension table is going to shared with the two fact table. So this is a fact consolidation scheme. So overall, the objective of this DBMS schema for decision support is to create a data with a multiple dimensional table. Through the multiple dimension table, the organization is going to take a great decisions. So this is what these three different models are help for the organization. Thank you.